So I am very pleased to introduce Tom Schenk. He's the Chief Data Officer for the City of Chicago and the Director of Analytics and Performance Management in the Department of Innovation and Technology for the city. Tom's a researcher and author and an expert in a number of fields, including open government, data visualization, business, and research in policy and education. He oversees the open data portal for the city and the advanced analytics team and the city's data and business intelligence team. I'm not going to say much more about him. We've got a bio in our bio printout for today, but I welcome you and thank you. I think there'll be great opportunities for some new partnerships with this city and others around the Midwest. So, Tom, thank you.
Good afternoon, everybody. It's great to be talking to universities from the Midwest. I'm a product of a large part of the Big Ten. My grad degree in economics is from Iowa State University. I worked for a time at Northwestern University in the Feinberg School of Medicine. So it's great to have some of those institutions here and to talk to the rest of you. So what I'm going to talk about today is how we use data in a very applied way in the city of Chicago to drive decision making. And something that we do very well in Chicago, within the city of Chicago, is to achieve this through partnerships. And today I'm going to talk about a number of different projects. So at time I might move a little bit quickly because I want to touch on a lot of different projects, because I know there's a lot of folks here from different backgrounds and want to see if there's anything that would pique your interest. Something that we're working on now or a potential for tomorrow. So you also get a portrait of how we engage and the mechanisms we engage, because frankly, we borrow a lot from academia. You'll hear references to not only open data, but you're going to hear references to open science, that principle that you're seeing really spearheaded out of academia of sharing research and collaborating around research and replicability, because those tenets are very important for governments today. So first off, I want to talk about the city's open data portal. I'm curious if anybody here in the room has ever visited the City of Chicago's open data portal. Can you raise your hands if you have? Okay, just a small smattering. And I'm not sure if anybody's been able to work with any open data portal. So open data portals themselves have really come into existence in the last 8 years or so. The federal government has an open data portal, data.gov. The City of Chicago's open data portal, which is data.cityofchicago.org. In the case of City of Chicago, contains over 600 data sets on a number of different topics. For instance, every single crime in the City of Chicago from 2001 to last week. That's over 6 million records. We also have where all the roads are in the City of Chicago, available in shapefile formats, the building footprints of the City of Chicago, all building permits, business licenses issued. Every 10 minutes, the water temperature and the turbidity of Lake Michigan at Chicago's beaches. For the last 4 years, Divvy, our bike sharing program, these blue bikes which you can go and rent out for an hour at a time and drive them to the next station and park them there, we have the availability of those bikes for every 10 minutes for the last 4 hours. So you can see where the demands are in the City of Chicago and where people are driving those bicycles to. So excellent commuting patterns. So we have a number of different topics because it pertains to what the City of Chicago does, which handles everything from public safety to making sure that your roads are clean to paying the bills. And so you can see all the payments that the City of Chicago has made, and that's also available. Not only is this available in a in a human readable format, but it's also machine readable. You can obviously download it into CSV, but it also has an application programmer interface. So every single one of these data sets has an API where you can go and fetch this information on a very regular basis. So this is an important thing that has been able to spark a number of different things. But this first step, and the City of Chicago was the first city, Mayor Emanuel was the first to appoint a municipal chief data officer who has the responsibility of not only just updating this, but to look for new and valuable information that we can put on the open data portal. And this is a first step of engaging outside of the city walls. Because now you can see the same data that we have access to. This data is updated automatically. We don't clean it and then post it. Every single morning it gets posted. Every single 10 minutes, obviously that's an automated script that's just taking the raw data and pumping out to the data portal. So you can see a number of different things. What you see behind me right now is in fact red light camera tickets. So you can go and you can see where red light camera tickets were issued, the patterns of that, and you can download the raw data behind it. And in 2012, Mayor Emanuel signed Executive Order 2012-2, which instantiated the open data portal where you can go and get this information. And it put the onus on the city to provide information to the public. Now, in one part, this is around transparency, showing others what the city of Chicago does. You can obviously file freedom of information requests, and you can have this, you get this information yourself. But what this does is make it more transparent, easier, reduce the cost for you to retrieve that data. Not monetary cost necessarily, but the time it takes to grab this data. I see this data sometimes appear in National Bureau of Economic reports, NBER reports. I see this in academic journals where researchers go and they simply retrieve this data and they incorporate that into an existing study to use their methods, to use their approach to find out something more and find out something interesting. And this is at the core of what we do. So in part of the City of Chicago's tech plan, we have a strategy C is what we call it, is to leverage data and make technology and new technology to make government more efficient, effective, and open. And you notice that that's a broader statement than just simply, we're going to post a bunch of data on the data portal. We already have an executive order around that. But how do we take it the next step? How can we take this data that we have and these assets and these problems that we have and make it available to others? And how can we leverage new technology to not just be more transparent, but to use this data to be, to increase the quality of life of Chicago's residents and to improve the efficiency of city operations? And as part of this, one of the goals that we have is the city will continue to increase and improve the quality of data available internally and externally, and facilitate methods for analyzing that data to create smarter and more efficient cities. Facilitate is a key word here. While we have data scientists on staff, and I'm myself am a researcher, while we can do that internally, we know that we're not going to be able to solve all the problems across 33 different departments, each of them having dozens of lines of businesses. Again, when you take a look at what we do, we're even bigger than a Procter & Gamble when you take a look at the scope of products that we're trying to offer. From public safety, again, from public safety to just simply paying the bills on time, to keeping the roads clean, to offering services around public health. So to do this, to use data in these different areas, it can't be done alone. It takes a number of expertise from a number of different areas, and we need to work with people who are thinking about this on a day-to-day basis, who are leaders in this thought process. And we update the public on what we do using our open data report. So you can go and you can see at report.cityofchicago.org the open data report where we mark progress in what we're doing and how we engage with the public. But the point of it is, where we start with open data, in a lot of cities, we've talked to a lot of cities, there's over 200 cities with an open data portal now. 8 of the largest 10 cities have open data portals. The federal government does. But it's more than just making data available online. Open data was originally around transparency, but it served to implement a catalyst to consider a greater data strategy. And that's what I'm going to talk to you about today. Is my position as a chief data officer is multifold, and one of that is really thinking about the data strategy. How can we use this to improve the city of Chicago? So by the open data portal, by releasing this data and taking a look at information that we're doing, it serves as a catalyst of conversation. For those who have looked at it and seen some data sets, you and I can talk right now about the things that you see. Just questions about what you do. How does the city of Chicago cause this problems? Why is there spikes here? Why is there flat parts here? Why can't you predict this happening? So that allows us to have a conversation in the open. You don't have to sign a contract with the city of Chicago to see information that's pertinent to us. And we've been able to see this in the city of Chicago because we've had these civic developer communities. Every single night, about 50 to 150 people get together, and this is our first year anniversary, and talk about what's happening in the city of Chicago through the open data portal, through data that they have access to, where they can create applications. For instance, to tell whether or not your car has been towed, because we make that information available online. Sometimes it's about making a prettier website, and sometimes it's about doing research because the data is available to them. I'm going to talk about a couple of those examples here today. But to further highlight the point about the importance of working together, the National League of Cities, when they did a survey of cities and how they use data, they specifically highlighted Chicago and its use of the open data program around its benefits to the city, residents, and others. And specifically, and I think they illustrated this very well because it's true, that we work with multiple stakeholders to make this happen. As you notice on here, that you see a diagram of city agencies, businesses, which you might expect, the community, which you just saw a brief video of, but also researchers themselves. Because to answer questions, and this is a key part, it's one thing to make it public, but we want to answer questions and we want to drive operational efficiency with data. And just a couple examples of how this has been used. Sweep around us, sweeparound.us. You get text message alerts the days that we're going to sweep your street so you can move your car. We put up the signs, but not everybody realizes the signs. The City of Chicago does not provide this service. A programmer came along and created this application using data that we made publicly available. Large lots. You can, in some areas, in some neighborhoods in the city of Chicago, you can buy vacant lots for $1 that the city of Chicago buys for $1. There's a number of contingencies with that. And large lots is it's an application you can go to and make and apply to this. And this is using data that's publicly available. So you can look up to see whether or not you're eligible. Again, this was not created by the city of Chicago, but by others who want to facilitate this program and make sure it was being used by others. ChicagoFluShots.org, a website that you can go and check where all flu shots are being offered across the city. This website has been in fact replicated in Philadelphia, Boston, and now San Francisco because others have now actually taken a look at this application and said, I like this application. And this application is not only available where you can go to this website and see it, but the source code is also available online as well. So both the data itself and then also the source code. It's an open source program. So other cities literally adopted it itself, took the code itself, and just made it available to themselves. And now we're starting to get into the power of replication and sharing not just data itself, but also the code that drives this. Because now we can replicate ideas. If we face the same problems across cities, why don't we just take each other's ideas and adopt them across jurisdictions? Chicago Works for You, chicagoworksforyou.org, a website that shows you by your local city aldermanic ward, your local councilman's ward, about the work that's been done, potholes that have been filled, and so on and so forth. So these are websites that were created by the community, technologists who are very interested in using technology and data to improve it. So think Lions Club, but for nerds, right? That's essentially what we're talking about in this era. We now have a constituency around technology, those who want to help their community. And instead of holding bake sales, instead of necessarily sweeping the streets or adopting a highway, they're trying to use technology to make that happen for their own community. But that may not directly apply to you, although some folks might be interested in that. And students at your respective universities are very interested in this. Most of these folks who have done this are younger individuals or college students in the Chicago area. So there's a great amount of interest there. Perhaps what you're more interested in is more of science and how we can use science in the city. Now, I believe he could not make it here today, but Charlie Catlett, who's a researcher at University of Chicago and Argonne National Laboratories, worked with the City of Chicago on a project called Array of Things. An Array of Things is a project of hanging sensors around the City of Chicago to tell on a block-by-block basis or on a micro scale what's happening in the city. Now, for instance, we can all go to NOAA and to the Weather Service and see what the weather is for the city of Chicago. We can download that forecast information. We can find what the humidity is. We can find what the precipitation levels are. But as climatologists know, and those who research weather, these weather collectors are done at the airports. So about a mile this way and then several miles south on the very edges of the city, because of course you can't put the airports downtown. But yet, when you go downtown, and almost on a block-by-block basis, as you move between neighborhoods, the weather changes. Some of it might be because of the urban heat island effect, where the concrete in the downtown area is retaining that heat, so it feels warmer. You get closer to the lake, the climate and the breeze changes. You move away from it, it changes. You move towards the parks, it can feel more humid because of the foliage in the area. So the climate changes, the weather changes across the cities you move across it. So on a block-by-block basis, we need to know some of this information that we might only know in remote areas or these surveyed areas which have been collected for a long period of time, but in areas that are not particularly interesting to us. So the array of things is each array, or each node as it's called, is in itself a number of sensors baked into it, such as measuring sound and vibration, so we can potentially tell when heavy trucks roll on by or when there's a tremendous crowd. Low resolution cameras, so we can count the number of people using visual intelligence, counting the number of people, but not in itself maintaining the video of those individuals, just by counting the individuals. To potentially see if there's close calls of vehicles and accidents and intersections. We know where the accidents happen, but we don't know where the close calls are. All right? So we can now start capturing information that we've never been able to have access to before. And what's very interesting that these sensors in itself and the data that they produce is going to be published online for free. I'll get to that in 1 second. But the sensors themselves are designed to be low cost and highly replicable. The sensors actually just got hung up, and we have, I think, about 15 hung up around the city of Chicago now, 15 of what will be 500 sensors. You can 3D print the shell that the sensors live in. The sensors themselves are developed by Argonne and designed to be low cost. And so these can be assembled quickly. The schematics behind these sensors are available. The software that's driving these sensors is available. So not only is it going to happen here in the city of Chicago, but other cities are going to adopt it. Cities like Seattle, cities like Amsterdam, and cities in the UK are working to adopt these array of sensors. Again, it goes back to sharing ideas across jurisdictions. And I mentioned there's going to be 500 of them around the city of Chicago, so it's going to produce a remarkable amount of data. And all this data is going to be available to the public. So it's not just a thing that the city of Chicago is going to hang up and the city of Chicago, the staff, gets the benefit from. But in fact, it's going to benefit you, and it's going to benefit a third grade teacher who wants to teach the basics of humidity to their class. It's going to be able to benefit high school and college teachers and professors. Anybody who wants to be able to access data will be able to access this data as well. So we're very excited by what other people are going to be able to do by this. Not just us, but what other ideas people are going to be able to bring to the forefront and what other researchers are going to be able to do. But the Open Data Portal is not sufficient for the community, but serves as just as a town square for us to debate. Again, this is where we're able to come together and discuss what's happening in the city of Chicago in an open way that doesn't require contracts and a bunch of legal work. Because we all know when you start going down that path, work just doesn't get done. You get fatigued, tired, and by the time a project actually starts, the grant's almost over. And so you're just rushing to get something done for your grantor. So the best opportunity for using open source is solving internal problems and then providing it as open source code. And we've talked about this a couple of times already. If we hang something like the array of things, or somebody develops code that can help improve information in the city of Chicago, we can share that with other jurisdictions because other cities have the same problems. Other cities have the same challenges as we do. So why try to reinvent the wheel? And in fact, earlier this year, I co-founded something called the Civic Analytics Network, which is based out of Harvard University and the Kennedy School, which is a network of 20 cities and my peers, of chief data officers across city, where we get together every single month on the phone and we talk about our problems. We have a very important principle of open sharing. Of sharing what our problems are and speaking openly and honestly. So we don't allow anybody else except for our network members, but it allows us to see and share we have the same problems and to steal each other's solutions. Because if I don't have a particular expertise on a topic, why should I try to reinvent the wheel when one of my peers already has come up with a great solution? Why not just take that solution, make my bosses happy, make the mayor happy, and move on to the next challenge that we have. We have no shortage of challenges. So the less time we spend on any one of them is just going to make my life easier and it's going to make the city better. To give you an example of this is going to be a bit of an abstract example, but one of the first use cases that we had around this was a package we call R-Socrata. And just to explain that the data portal that we have, the data portal, the vendor's name is Socrata. Right, so this is our data portal. So you can go and you can grab information from this data portal. Well, we like to use R. Our data scientists love to use R. I manage the data portal, and I manage the data science team, and the data scientists love to use R. I'm an R user myself. And we're sitting there and we keep downloading data from the data portal for our research projects. And we wrote all this custom code to be able to do that because it was tedious and we were doing it over and over again. And we thought to ourselves, you know what, this is actually a pretty good solution for us. It's probably a pretty good solution for others as well. So we created an R package, or R being a very popular programming language for researchers and data scientists these days. We created a package where the code became very easy. So for instance, to download all the employee salaries in the city of Chicago, you just load up the library. That's that first line of code. I can list all the data sets on the data portal using a very simple line of code of data.cityofchicago.org. Show me everything that's there. And then I can just download the salaries by just using the URL and just copy and pasting that in there. And all this tricky logic that's happening behind the scenes is being done. Well, since we've released that, other cities have actually founded their analytics program using this package, grabbing data from the open data portal. Because when it's open to the public, it's open to other city employees. I think Puerto Rico, in fact, uses this package to update their data portal because of some features and functionality that we have. Things that we didn't even imagine that would happen was happening. That function, that ls Socrata function that you see right there, wasn't even created by us. It was a programmer at the University of Washington who found the package. He goes, oh, hey, you could do this as well. Maybe you just want to list all your data sets. Here, I wrote that for you. We've had over 200 hours of programming time volunteered to City of Chicago projects by just making it available. People coming along saying, hey, I got a better feature for you, or hey, here's a bug fix for you. Over 200 hours. That's over 200 hours of staff time that we've not had to devote, to hire, to pay, to add new features. This provides longevity to projects. It provides longevity to projects because in government, as soon as you're done with it until it's an emergency again. Right? You move on to the next thing because you're being asked for the next thing. But now this allows other people to keep their eyes on the project, to let you know when something's wrong, to fix that for you, to provide new features without always having to turn back to these older projects and rethink of what you've done. There's projects where I've worked on and I've never touched again because that was it. But yet, it might have still been useful. So this is a great way to add longevity. But this is all very light in the sense that this is all non-critical. The City of Chicago would function if this package doesn't work. So how do we answer more critical questions? So take the City of Chicago, 235 square miles. All right, if you flew in, you saw something that looks like this, 235 square miles. So how can we tell what's happening in the City of Chicago? That is, if I want to look at something on the north side, the south side, and the west side, how can I tell what's happening there? Well, the Open Data Portal does a good job of making it available online. For instance, what you see behind me here are 311 calls for potholes reported. Right? A very classical, critical thing for residents to be angry about. And therefore, we're highly incented to make sure that we're fixing the problem. But this list of data doesn't do a great job of providing information. It provides data, but does not provide information. So the City of Chicago created a new project called OpenGrid. And OpenGrid is a situational awareness platform that the City of Chicago uses, and you can actually have access to as well. You get the what you can access at OpenGrid.io is the version that uses open data. But we have an internal version of it that we use. It's the same code, but we load it with more data. For instance, 911 calls. We load it with weather information. We load it with tweets, any tweet that was geocoded in Chicago, where we can take a look at this and we can use it for situational awareness. So now you can select and highlight areas of the city and see what's happening there in real time. Or you can get a more cursory look by creating heat maps and chloroplasts to see what's happening across the city of Chicago. I'm going to skip past this next slide, or let me put it this way. Let me back up a little bit. This program, which is an open source program, is in fact a collaboration across a number of different projects. The University of Chicago, they worked on this project called Plenario. And what Plenario does is it allows you to ingest information and bring it all together from different sources. So we have 911 data, we have 311 data, we have tweet data, we have business licenses, we have crimes. How do you bring this data together and display it all together? And how do you warehouse that information? Well, the Plenario project was simply a back-end project, which said, hey, all of this data with events is a point in space and also a point in time. So let's normalize around that. Let's have it so any data that has a latitude and longitude or an address and has some sort of timestamp on it, we can bring that data in and you can display it uniformly. And that served as the backbone to OpenGrid. If you go to OpenGrid right now on your desktop or on your mobile phone, you can see what's happening around you. You can use your mobile phone location and actually see what's happening around you. So by building on top of what the University of Chicago had already done with their open source project, Planario, and by putting our user interface on top of that, and by leveraging things like our databases and our open data portal, we can bring this project together as a more complete platform. Because Planario didn't give you a nice user interface to be able to see this. Planario itself was grabbing data from the city of Chicago. So we created an interface that worked well. And the University of Chicago, when they did this project, they spent, I think, $350,000 in an NSF grant. The city of Chicago, we spent $250,000 of our own money in development time. So together, we can go to our grantors and say, not only do I just have a $350,000 project, but we teamed up with the city of Chicago who put their own time into this project. And now you can go back to the NSF and say, hey, we have a $600,000 product, not just a project, but a product, a $600,000 product that's open source and can be adopted by other cities. And again, OpenGrid is being adopted by other cities and by universities for their own purposes. The city, again, the city of Seattle is going to be one of the early adopters of this. And the Array of Things program I was talking to you about a little bit before is going to be feeding that data so you can also take a look at that data in this platform, this OpenGrid platform. So by being open source, by making data publicly available, again, we can collaborate in ways that are very easy. It's very easy to define intellectual property rights when it comes to open source. University of Chicago owns the copyright of what they developed. City of Chicago owns the copyright of what we developed. But we license it in a way that allows each other to use it and allows it to be adopted by others. So the intellectual property concerns, easy. Sharing code, very easy in this era, using open source repositories and using those practices. And then the third component, and the most critical component, is collaborating. And that's the real value here, right, is the collaboration of this all. So $600,000 of actual money spent, of time spent on this. But it's that collaboration where we can come together and create something of great value. So I want to touch on some research that we've done. We've talked about platforms where you can create and you can visualize information. We've talked about sharing data. But how do we actually solve problems? So let me give you this problem behind me. We have 15,000 restaurants in the city of Chicago. While you're here, you should visit some. We tax those restaurant bills, so please contribute to us. But we have 32 inspectors to inspect them all. 15,000 restaurants, 32 inspectors. All right, so for those who are in this room, for researchers, like, okay, all right, I see the problem. How do I take the inspectors and how do I find the places that actually matter most? This is a queuing theory problem. Where do I visit first? And where can I deprioritize because it's not going to be a problem? Why randomly go across the city? Or not even randomly, can even a human do a good job of sorting which ones are going to be the most important versus the least important? And again, 235 square miles for the city of Chicago, 235 square miles. So this is a geographical problem as much as anything else. How can we spot these areas across the city and pinpoint on them? So again, the optimization of this is, I have a list of restaurants that I used to do in a particular way. Is there a way that we can reorder that list that would be more efficient and find critical violations earlier? And remember at the end of this, though, this is not just a research exercise. We actually want to drive decision making. Because at the end of the day, there is somebody who's in a kitchen, digging through, going into cabinets, using flashlights, opening drawers, looking at refrigerators to make sure that it works. So there's on-the-ground decisions that are happening, on-the-ground work that is happening. And that's what we're trying to improve. So it's not just a theoretical exercise, but something that can lead to better action. And what's interesting about this is a lot of the important data was already available on the Open Data Portal. Now, to clarify, This research project I'm about to describe could be done internally without using any public data. We could have just gone to our own databases and pulled out the information. But for this project, we deliberately reached out and only used data that was publicly available for a very big reason that I'll explain at the end. But I just want to clarify at the up front. So we have, for instance, all the food inspections for the city of Chicago from 2011 to present. So you can go and you can grab this information. You can grab other data, such as people complaining about rodents, people complaining about garbage in their alleyways. You can go get crime data. So you can grab all this piece of data together, and we did that. And our data scientists looked at this data and found good predictors. We did the typical research exercise of fitting regressions to look at multicollinearity, to do the research exercise. But at the very end, we came up with a list of significant predictors. Restaurants with previous critical violations, those who have had previous critical violations. And I should mention too that we're focusing not just on restaurant failures, but critical violations, those violations are most likely to lead to foodborne illnesses. For instance, not keeping food cold enough or not keeping it hot enough when you need to. The 3-day average high temperature before an inspection, the high temperature, the hotter it gets, the harder it is to maintain cool, to keep your food cool when it needs to be cool. Risk levels, the location of the restaurant, nearby garbage and sanitation complaints, the type of facilities, the density and frequency of nearby burglaries, whether or not the establishment has a tobacco or has an incidental alcohol consumption license, whether or not you're allowed to sell alcohol, basically. The length of time since we've last been there. Have we kind of derelicted you and not been there for a little while? And how long have you been open? Are you a well-established practice or are you still new? So all these different variables, it seemed to fit well. Using statistics and what we do, it seemed to fit pretty well. But that's not good enough. Right? We want to know whether or not that guy who is digging through the refrigerators is going to be able to find inspections more frequently. So we ran an experiment. A double-blind experiment where we trained the model, we'd done the training of the model, and then we let 4 months pass, and we didn't put any more data into the model. So we let some time expire. And then we essentially said this: for the next 2 months, go do your inspections. And we're going to quietly and privately create a list of places you should have visited ahead of time. This was in the beginning of August. So we have our secret list, and then they actually went and did their work. And the goal was compare our secret list versus the work that they've actually done and see which one would have done a better job over the next 2 months. And here's what we found. Now, you would expect over the next 2 months that in that first month, half of the critical violations would have been found. You know, half in the first month, half in the second month, right? If it's random, if it's purely random. But it's not purely random, right? There's a manager, a food inspection manager who's very experienced, who's targeting places based on where she feels is going to be the most likely to find critical violations. And she knows the frequent violators. She knows that there's certain areas of the city and certain restaurants that have that. And she knows to send her inspectors there. So what we found was about 55%, a little bit more, not statistically significant, but numerically interesting enough, 55% of the critical violations were found in the first half, in the first two quartiles, essentially. In the meantime, if it was following our protocol, 69% of the violations would have been found in the first half. That is, we would have found the critical violations earlier, and then the last month, the second month, would have just been pro forma checks. Just checking places, because we have to check places, we still do, but these would have been the less critical violations. And let me tell you, what's interesting about this, about halfway through the experiment, I got food poisoning. So I got to experience why it was important to find those places earlier, so I'm not sitting there in the urgent care clinic with an IV in my arm, hating life. Right, just absolutely sick. So not only it's a few $100s of medical care that you forego on, it's obviously the unpleasantness. It was missed work. Fortunately, I have paid sick leave. For those who don't have paid sick leave, that would have been even more money out of their pockets. Right, and of course, clearly more serious things can happen with food poisoning, though it's less frequent in this era in the United States. But this is still something that has to be contended with. So what we found is over an 8-week period, and it's important to contextualize this number within 8 weeks, with an 8-week period, we are finding critical violations on average 7 days earlier, a week earlier, 7.4 in particular. I was very upset it wasn't 7.5, so I could just say 8 days, but had to be honest. So 7.4 days earlier of the 8-week period. And this is perhaps my favorite graph of it. This is showing the progress of the inspection process. Now, on the x-axis there, it shows the number of inspections completed over the 2-month period, a little over 1,200, about almost 1,300 inspections, I believe, that were completed over the 2-month period. And on the y-axis, it shows you the percentage of critical violations found. So by the end of the thing, you find all your critical violations, and that's it, right? So we're all getting to 100%. But it's the path to get there of what we're focusing on. Now the red line shows what the business as usual, the status quo method of doing it, and what they were able to do over that 2-month period. It shoots up. Is about when they get to around halfway through, about 600 inspections. Indeed, they're a little over 50%. This was the number I showed you earlier with the bar chart, but we're just expressing this in the line chart now. So that's interesting. But the blue line is the path to get there when we're using a data-driven method. And that blue line from day one was finding more violations. From day one, finding more violations. And in fact, by the time you got to the last week, we found all the violations. And we found no more critical violations. So we had hit 100% a week out. And we're still doing checks. We're still doing the work that we need to do. Not only because we need to do it, but we also need to feed into our analytical model to make sure that these places were okay. So we're able to find more quickly. So that gap between the red and blue line, that integral between that red line and blue line, that's really the total savings, that total time saved that we're able to get. And again, it's not just about saving money. In this case, there's really no money saved in this. This is about getting to places earlier to save people from getting sick. So it's driving those day-to-day decisions. So what does this look like for somebody, though? What does this look like? Okay, we did a research project. We found there was a relationship. We did a study, right? A lot of people have done that. But we operationalize this research. Every single morning at 5 a.m., because we have a series of computer scripts that set up to do it, the food inspection manager gets to look at this screen. It's a list of all the restaurants in the city of Chicago and the probability that they're going to fail that day based on the most recent information that we have. Again, all taken from the data portal. So at 2 a.m., we update the data portal, and we start downloading that data on the other side with these analytical scripts. And we calculate and we retrain our model. We weight all of our variables again, because that is probably not stationary over a long period of time. Things become more and less important. And then we provide our predictions. And this is based on what she wanted. She just wanted a list. We said, do you want a map? No, I don't want a map. Just give me all the restaurants. Let me search it easy. Let me export it to Excel really easily. Let me sort it by the highest to lowest or alphabetically, whatever you want. So it's kind of like an Excel spreadsheet a bit in a website, but that's precisely what she wanted. And see, she can use this as well. She uses this to dispatch her inspectors to tell which restaurant to go to, but also uses it sometimes to help mediate information. Sometimes she'll get a call and she goes, you know, this restaurant is terrible, it's awful. And she goes, looks at the past inspection reports, goes, you know what? Nobody's ever really complained about this before, and you know, our last inspection wasn't bad. And she has a choice. Do I send an inspector there for a half-day inspection, or do we do a short visit just to check in? And sometimes she uses the model to kind of mediate that when she's on the fence. She goes, okay, what does the model say? If the model kind of has it high, then yeah, we'll do a full inspection. If it's kind of low, we'll do a short inspection. So she can help mediate some of her decision-making process through this. But I kept hammering on that this data was from the open data portal. And the reason is this. The code that's driving this model is available online. Because the data is publicly available, that means when we make the code available, it allows other people to also run this code. And I told you about the experiment that we did. The experiment is well documented. So you can find out what we've done and to be able to replicate the results. So one of the open science is just pure replication, what journals often are trying to do, to make sure that when we say there was a 25% gain in efficiency, that we actually mean there's 25% gain in efficiency and we have some way to relate that back to an actual number. So that's great. That's transparency. That's fine. But even more interestingly, can you beat our model? Can you take data and other data that you have access to and beat our model? And if you beat our model, we will take your code and your model will then drive the city of Chicago. And that's compelling for those who don't work for the city but want to make an impact. It's like, really, I can code something and make it better. For a grad student, I can code something and you guys will actually use this for a model. Yes, day to day, you will have people acting differently because of your contributions. And we've had people who have tried really hard to beat our model. So far, nobody's beat it yet. But it was funny, during this open review process, somebody did come along and had great results. He said, you know, I just submitted a request for you to look at my code. I have you guys beat, right? And he gave us a summary of what the results were, and he go, wow, that is a good model. We saw what he did. It's like, okay, we can make sense. That makes sense. He might have been able to do a better job this way. But when we're looking at his code, because you always have to do this, we're looking at his code and making sure it was okay. We realized that he made a spelling error and accidentally included data he shouldn't have included, which fudged the results. So that open review process, again, what so much in academia is being pushed on for replication to make sure that these results are valid, are very pertinent for us today. Not only to show what we've done and to challenge others, but when people want to say, I can do a better job, show me. And let's take a look at it. And if you do a better job, we'll use it. And if not, if you have made some sort of mistake, it was a very earnest mistake, then we won't. Then we won't. So this is really important because, again, it keeps the eyes on the project, because there's people who are trying to do a better job today on this model. And none of my staff are spending time on that. I'm not spending time on that. But yet there's still attention paid to this. And that's very positive. That's very, very good. And that can only lead to better outcomes for the city. Oh, sorry. You can go and you can find a little bit more information on this website that I have right down here. It's a good one-page summary of the project, but perhaps even more interesting is the technical documentation that we have it. So we have in a sort what would be considered a white paper or something that you would see akin to in a journal. And this is us playing around a little bit, frankly. We're playing around with this a little bit. So this technical documentation is driven by fully reproducible research. So that PDF that you see is actually a series of text and R code that gets generated into a final result. So if you're reading a sentence, we did this and it led to a 25% increase and led to 7.4 days earlier, you can actually go back and look at the actual code that generated that estimate. I mean, sometimes I've written summaries of research results, and 6 months later, I can't remember how I got that number, right, in all earnestness. Well, this really allows you to tie that linkage. Again, this is coming right out of the open science movement. These lessons are coming right out of what we're seeing in academia. Now, we're not going to do this all the time. This was us playing around and experimenting with the edges and pushing the edge of what can we do and how much time does it take to get fully reproducible results. But between the open data portal, leveraging open source software, publishing our code open source, and this reproducible research, you can tie the data itself down to the number that you see in a white paper. That's full reproducibility. Full reproducibility. And that allows us, again, to collaborate with others that haven't been able to be done before. So combining open data, the open source, and that engagement model, we can do a better job, and we can partner with academia, we can partner with technologists, we can partner with students and other cities in ways that haven't been able to be ever done before. And that's very exciting. So how else have we used this model? So in a project that we just finished up, summer just wrapped up, so the project just finished up, some folks noticed that Chicago's beaches have high E. coli levels sometimes. Now, the USGS, the United States Geological Survey, created an analytical model which predicted E. coli levels in Chicago's beaches. We released all that data on the data portal, and people noted the model's not that good. And it wasn't that good. It was only right about 5% of the time. So we engaged with technologists, said, you know, we don't have a lot of time to work on this project, but if you create a better predicting model, we'll use your model. And indeed, from November till May, between 7 and 12 data scientists on a week-to-week basis would work to create a better model. And by May, the end of May, a week before the beaches open, they said, we got a better model. And they demonstrated it, and so beginning this past summer, we used their model. So this is not something where we even first did the work and then had somebody check our homework. This is work where we defined the problem, we released the data, and somebody else, actually a handful of people, more than a handful of people, did the work themselves and were able to give it to us in a way that we could use. So I like the asymmetry of that. It's not just about us doing the work more and just putting a ton of stuff online, which may not be digested, but instead allowing others to make a contribution to the city. just want to touch on one last thing that you might be very interested in, underground mapping. So everything I've talked about before are things that happen above the surface. And we're partnering with UI Labs. I think there's a rep from UI Labs here today. We're partnering with UI Labs, a consortium with industry, universities, and cities, to map what's happening underneath the ground in the city of Chicago. So this is a map of an image. In the middle here, you actually see an image. Around it is a cloud point map of subsurface structures. So while we know a lot of things are happening above the surface, we don't know much that's happening beneath the surface. This map was created by University of Illinois, Urbana-Champaign, where researchers there have worked on translating images taken by a camera into these point maps, which can then be turned into 3D models and have been turned into 3D models of substructure Chicago. So you start with an image. This is the image that was literally taken, and then ultimately turned into this image here. So this process of taking a photo into a point diagram into a 3D model is something that we've been working on, I think, for the last year and a half now, and we're going to expand the pilot out for the City of Chicago, which we'll be working on for another year and a half, which involved a number of partners to get this to happen. UI Labs, or City Digital, a project under UI Labs, HBK Engineering, Accenture, Microsoft, the City of Chicago, ComEd, University of Illinois, Esri, and a startup called City Zenith. To be able to complete some of these projects often takes a lot of manpower, takes a lot of knowledge, and a lot of experience of folks who are trying to take something, not just a one-off research project, but to take it the full cycle from gathering data to the point of using that information, whether it's in predictive analytics, collecting things that happen underneath the ground in the city of Chicago, or downloading data from our open data portal and just simply using it. So I'm getting close to the end of time here, so thank you for having me out here. Thanks for listening to me here today. Just a couple minutes for questions if anybody has any. Yes?
Thank you for that. It was really interesting. You mentioned copyright and licensing, and you were talking about the smart cities work with, I think, with Argonne in that reference. So the copyright licensing is in relation to the data?
Both.
Okay.
Yeah, and we've had some interesting conversations about that. So it can apply to both, and in the Array of Things project in particular, University of Chicago and Argonne National Labs own the devices, the intellectual property behind creating these devices, and in this case, they also own the data. And some of the reasons of choosing that was also to best position privacy as well, because universities are going to be highly protective of turning over data and things that would be sensitive, and we want to best protect sensitive information that this might be collecting.
Okay, but then you had also said that you were licensing to them, in copywriting and licensing data to them. What is that?
So for instance, all the data on the data portal is licensed, is copyright City of Chicago, but it's licensed openly in a way that anybody else can use it. So the copyright stakes ownership, says we own this entity owns it, but then licensed in a way that is permissive, which essentially usually says you can use this however you want to, as long as it's not for illegal purposes, and don't sue us because we're not providing a warranty on it, and don't use our name saying that we somehow blessed your thing that you made from this, because we just simply provided the data. So don't use our logo or use our name in that sort of way.
So often groups and research will use data use agreements for that kind of, of representing that kind of terms, yeah. So your license is it a Creative Commons license, or is it more along the lines of a data use agreement?
It's highly adopted from not so much Creative Commons, but from other open source licensing, such as MIT licensing or Apache licensing. We usually take elements from those. Sometimes, for instance, with licensing, you want to say, hey, you can use this, but I still own the patent on this. Just to be clear that I own the patent on this, but you can still use the information or you can use the data. So we often will take it from a number of different aspects and piece together something that works well. But instead of doing one-to-one data use agreements where you and I have agreed to share the data, it's more liberal in the sense that it's me and the world can share this data and use this data in this sort of way.
Yeah, no, these use agreements are usually big projects,
Yeah.
big databases like biodiversity database. GBIF has a data use agreement for all of its data. Yeah.
Yes,
Okay.
yes, yeah.
Okay, good. Thanks. Good.
Yes.
I was curious about thanks for the talk. Very interesting set of projects and very progressive. I'm an economist and have seen some of these MBR papers, and am really interested in the experimental aspect of what you're doing. So I think it's cool that these data are available now, but what is really different that I didn't expect, was kind of a surprise, was the capacity for the city to actually run an experiment. And that, I'm wondering, so that's over and above, in your sort of strategy to involve other researchers, I think that's extremely compelling. And to the extent that the city is interested in developing and running experiments, I think you'll get a lot of attention. And direct contact with researchers. And I'm wondering if you have a particular program or kind of strategy developed around that to kind of expand.
I think you're looking at that strategy a bit of working with groups like Midwest Big Data Hub or UI Labs or other research consortiums, making them know that these projects exist. This is something that can be done, and there's a willingness to it. And if there's interesting research projects, to reach out to the city to let us know and consider it. Now, the downside of it is we can't consider a ton of projects. There's a lot of interesting experiments that you could run, which could reveal interesting relationships. But the framing of this is we're interested in things that can lead to operational improvement immediately. And that's usually where we're always framing our experiments and our research. Yes?
Yeah, I was wondering if you could elaborate up more on the history of your community of citizen developers, and then maybe provide suggestions on how you can grow that base of developers.
Yeah, so it was a small group. It's about 5 years old now or so, where it really started with the Open Data Portal. Early on, even preceding the Open Data Portal, you had journalists who were very interested in transparency for very obvious reasons. Researchers who obviously would also benefit a lot from greater data transparency. So when Mayor Emanuel came into office, in the transition report saying we're going to focus on transparency and things like an open data portal, including creation of an open data portal, that really got a lot of excitement in the community. Now, I think what the city of Chicago did well is we harnessed that. Now, I don't run these groups. I don't run the week-to-week meetings, but I interact with them on a week-to-week basis. I'm not a hard person to get a hold of because it's that energy and the enthusiasm of doing work. If we can point that in the right directions where work can be really meaningful, that's what's important. Now, there are people who show up to these hack nights and these hackathons and these other different events who are interested in not necessarily maybe working with the city, they're interested in exploring particular social issues, and that's fine. But for those who do want to make an operational impact, I will bring to them, and we will bring to them, ways that they can make an improvement on their city. And I think that's what today's generation, around technology in particular, can respond positively to. Knowing that this isn't just an idea or a weekend hackathon. I'm very negative on kind of weekend hackathons for mature communities because nothing usually happens with those projects. Early on, in the first intervening year, it's great to bring people together to just even know that there's somebody else in your city or in your university that has an interest like this. That's very important, but as you mature, you got to move away from that, hey, let's just do something crazy and not have anything come from it. And really keep thinking, how can we make you enable you to make an impact on your community? Yes?
This is addressing a different sensitivity. For example, Chicago's pretty much in the limelight because of arrests and murders and things like that.
Mm-hmm.
Are you restricting that kind of open access to information?
To an extent. So for instance, the City of Chicago has crime data on the data portal, which speaks to the heart of it. And there's very interesting things that can happen. A couple years ago, there was a debate of how many homicides happened in the city of Chicago, because journalists or newspapers would still keep track of it. And there's a threshold of 500 homicides that was particularly important because notable, just numerically notable. But there was a debate whether or not there was 501, 500, 499, and you had this very open, transparent discussion, because I think the city of Chicago said there was 499, a couple other organizations had one or two numbers off, and there was this very open conversation about how are you considering this, and it was very intriguing to see this play out, and everybody expressing their opinions. Now, obviously, there's a certain amount of data that we can't make publicly available, though there are researchers who have partnered with the city of Chicago and CPD in particular around, for instance, gang networks or contact cards. So usually this is now starting to deal with information that deals more personally about an individual. For instance, the crime data, we call it block reduction. You know which block the crime happened, but we didn't tell you the address because that would be going too far. So usually when we start getting into areas where just raw privacy becomes a concern, then it's not about publicly available, then it's about signing a contract and an agreement, which we're completely open to. The open data portal is just a way, is in part a way to begin this conversation, so you know that this is an opportunity for you.
So I think we need to wrap it up now, but thank you all for the questions, and we want to thank Tom Schenk for coming to see us this afternoon.
Thank you.